Hello. We welcome you to our course on seismic assessment and retrofitting of existing reinforced concrete structures using Seismobuild and Seismostruct. The course is organized by Seismosoft and it is divided in two parts with 3 and 4 modules respectively. In the first part, we will introduce the main methodologies for the seismic assessment and retrofit of existing reinforced concrete buildings. Then, in the second part we will see how these methodologies can be applied in the case of real existing buildings with the use of Seismosoft's programs, mainly Seismobuild but also Seismostruct. The first part consists of 3 modules and provides general information about the assessment and strengthening of existing reinforced concrete buildings, the different strengthening techniques, the types of analyses, the necessary capacity checks, and how these are applied in the different standards worldwide. In Module 1, the basic question, why reinforced concrete buildings need strengthening, is addressed, and it is explained how reinforced concrete buildings are built by presenting their main deficiencies and problems that cause their increased vulnerability. We will present the main deficiencies of older reinforced concrete structures that have been built without specifications for seismic resistance, and we will explain how these deficiencies adversely affect the structural strength. The main problems are: the lack of stirrups, the soft ground stories, the short columns, problems in the foundation system, the short lap splices, and several other problems that make older reinforced concrete buildings vulnerable to earthquake actions. Next, the main standards for the seismic evaluation and retrofit of existing structures will be presented and the main differences between the assessment and the design methodologies will be discussed. This basic difference between the design of new and the assessment of existing buildings are reflected to the different standards that are available worldwide. The different methodologies for structural design and structural assessment will be presented and it will be explained why both in the US and in Europe the documents and standards for structural assessment and strengthening are different from those for the design of new buildings. Furthermore, the challenges imposed to engineers in structural assessment and retrofit with respect to new construction will be presented, and it will be explained why the entire process is more complicated and difficult, due to the architectural and operational restrictions imposed by the existing building. The new concepts, like the knowledge level and the confidence or knowledge factors, will be described, and it will be explained how to treat both new and existing materials in the same model. The basic differences between the methodologies for the design of new and the assessment of existing buildings will be explained, both in terms of the building input provided in the structural analysis software, but also in terms of the output and the deliverables of the process. Finally, the main features of an on-site building investigation are presented. We will discuss the details of a building survey, the geometric measurements, the reinforcement scanning, the testing of the construction materials, and the destructive and non-destructive material tests. The details of a program for experimental testing in a typical building will be given, and the destructive tests for concrete, steel, and the infills will be presented. Furthermore, information on the concrete non-destructive testing will be provided, as well as information on how to scan the reinforcement of the concrete members with the typical Ferris scanners that are available in the market. In Module 2, the main techniques for strengthening reinforced concrete buildings will be described. In the first part of the module, the main techniques and their advantages and disadvantages will be presented, including reinforced concrete jackets and shotcrete, new reinforced concrete shear walls, steel braces, fiber reinforced polymers and FRP wrapping, FRP laminates, steel jackets and steel plates, base isolation, Damping devices. Resin injections and repair mortars. And the strengthening of the foundation system. In the second part of Module 2, the advantages and disadvantages of each method will be discussed by means of a simple evaluation example. An existing RC building with a soft ground story will be strengthened with different seismic retrofitting techniques. Using pushover analysis, as well as nonlinear dynamic analysis. Apart from plots and graphs, the structural response will be displayed by means of videos, with which the characteristics of each method will be better explained. In Module 3, the main concepts of the performance levels, the performance objectives, the checks that need to be carried out in an assessment or retrofit project, and the different methods of analysis, linear and nonlinear, will be presented. The performance objectives and the performance levels will be explained for the case of the American standards, and for the case of the European standards. The 4 different methods of analysis, both linear and nonlinear, will be described, and their advantages and the disadvantages will be presented, together with the modeling requirements in each case, and the limitations in the use of each one of the methods. Of course, more emphasis will be put on the nonlinear methods, in the pushover analysis, but also on the nonlinear dynamic time history analysis. Whereas some advanced subjects, such as the selection of the seismic motion for the dynamic analysis, will also be covered. Finally, we will pass through all the required checks in structural assessment, noting that these checks are not the same with the checks in the typical design methodologies. Also noting that different checks are proposed by the codes in the linear methods of analysis and in the nonlinear methods of analysis. Within this context, several new concepts will be explained, such as the classification of members to primary and secondary, the classification of actions to deformation and force-controlled, or alternatively to ductile and brittle, the expected and the lower bound material strengths, and the knowledge and the confidence factors. The second part of the course consists of 4 modules that will present SeismoBuild and SeismoStruct, 2 packages that are specialized in the analysis, the assessment and the strengthening of existing structures. In Module 4, the introduction to SeismoBuild will be done. SeismoBuild is a software package dedicated to the structural assessment and retrofit of reinforced concrete buildings, employing the code-based methodologies with the linear, but mainly the nonlinear analysis methods. The main functions of the program will be presented by means of an example. A 2-story reinforced concrete building will be fully modeled and checked, and we will follow all the steps of the assessment procedure. The introduction of the structural members, both the geometry and the reinforcement by means of the so-called reinforcement patterns. The definition of the material strengths. The input of the main code-based requirements according to the selected code. The performance levels. The methods of analysis and the loading patterns. The seismic action. And the checks to be performed. Then an eigenvalue analysis will be carried out, together with the necessary pushover analyses. Finally, the results from the checks will be obtained. The CAD drawings will be exported, and the technical report with all the checks will be created. In the next Module 5, a more detailed description of SeismoBuild will be given, and some advanced issues will be discussed. In order to provide feedback on all these issues, 2 tutorials will be presented. In the first, a relatively complicated model will be created, analyzed and assessed, and in the second, the same model will be strengthened and analyzed again to pass all the code-based checks. Amongst other things, what will be discussed is the introduction of different foundation levels, how to insert additional longitudinal rebars, how to define inclined beams and slabs, how to define stairs, the multiple edit and the copy properties functions, and the advanced member properties and the modeling parameters. Finally, the different methods of strengthening will be displayed, including reinforced concrete jacketing and FRP wrapping. Then in Module 6, we will discuss how the code-based procedures for assessment and strengthening can be applied in real projects using Seismobuild. This will be done through 2 characteristic case studies. Apart from the presentation of the existing buildings and their characteristics, you will be given their Seismobuild input files and you will try to model their strengthening and carry out the seismic retrofit procedures. The first is an industrial building with short columns. It will be analyzed with different analysis methods and the capacity checks will be performed, and the problematic nature of short columns will be confirmed. The capacity checks will be carried out, and the effect of the infilled walls will be studied. The role of the selected method of analysis, linear or nonlinear, will be investigated and it will be demonstrated why the nonlinear methods are more appropriate for the analysis and assessment of existing reinforced concrete buildings. Finally, the building will be strengthened with 2 different methods and the structural response, with and without the strengthening, will be compared. The second building will be a residential building that has been severely damaged by a recent earthquake. Again, a full structural assessment of the existing building will be carried out, and the checks will be performed. Then the strengthening scheme that has been employed in reality will be applied, the analyses will be carried out again, and the comparison with the existing, damaged structure will be done. Finally, in the last Module 7, we will see how one can pass from Seismobuild, which is simpler and easier to use, to Seismostruct, which has more advanced modeling capabilities. An introduction to Seismostruct will be given and the main features of the software will be presented. Then, through a set of tutorials, you will learn how to use the program, and how to transfer your structural models from Seismobuild. If you need more information about the course on seismic assessment and retrofitting of existing reinforced concrete structures using Seismobuild and Seismostruct, you can visit us on training.seismosoft.com.